And now in this lecture we'll find out the value of x. In the drawing we have a quarter circle. AFE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, we know that this is line segment DE, this is equals to 12 units in its length. This is angle GDC, that is equals to theta. This is angle EDC, that is also equals to theta. And our mission is to find out the length of this line segment DG. Our mission is to find out the length of this line segment GD, that is equal to x. We have to find out the value of x. So first of all, note that all the angles inside this square ABCD are right angles. So this angle equals to 90 degrees in size. This is also a right angle. This angle is a right angle. Finally, this angle also equals to 90 degrees in its size. In addition, you know that the opposite sides of a square are parallel to each other. So in square ABCD, it means that side DC is parallel to the opposite side AB. So write it down. Side DC is parallel to the opposite side AB in square ABCD. But here, side AB is part of the straight line AE. Again, side AB is part of the straight line AE. And so if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, the straight line AE itself must be also parallel to DC. So AE, the straight line itself must be also parallel to DC. AE is parallel to DC. Here we can implement rule 15. I'll read quickly on rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A, this is line A, this is parallel to this line B. In addition, we have here those two angles that are defined as alternating angles, and they are located between the parallel lines A and B. That is to say, line A is parallel to line B, and therefore they are equal to each other. Whenever we work two alternating angles that are located between parallel lines must be equal to each other. Okay, therefore those two alternating angles that are located between the parallel lines A and B are equal to each other. That is to say, alpha equals to beta. We can implement rule 15 in our drawing. In our drawing, we have those two angles. Those two angles are defined as alternating angles, and they are located between the parallel lines DC and AE. DC is parallel to AE, and therefore they are equal to each other. So actually, this is angle EDC. And this is angle AED. So angle EDC equals to angle AED because of the fact that those two angles are defined as alternating angles, and they are located between the parallel lines AE and DC, and therefore they are equal to each other. But this is angle EDC that is equal to theta according to what is given as the equation. So can I tell that angle EDC equals to theta? And for this equation, theta equals to angle EDC equals to angle AED, we will derive that angle AED is also equals to theta. Angle AED is also equals to theta. This is angle AED, it is equal to theta. In the next step, we will do a construction. That is to say, from point G, we draw perpendicular on AB. Again, from point G, we draw perpendicular on AB. So actually, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point of the perpendicular GN with side DC of this square ABCD as M. So by doing this construction, we created quadrilateral DMNA. This is quadrilateral DMNA. Inside this quadrilateral DMNA, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral DMNA to 360 degrees, this missing angle must be equal to 90 degrees in its size. So inside quadrilateral DMNA we have 4 right angles, and you know that any quadrilateral that has 4 right angles must be a tesseract angle if not a square. So we write to this quadrilateral DMNA as a rectangle. So I write it down, quadrilateral DMNA is a rectangle because it has 4 right angles. GN is perpendicular on AB. So GN is a perpendicular, it is absolutely a straight line. So if you focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees, according to rule 3 that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle, plus the missing angle. In total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. And therefore the small triangle DGM is a right triangle. So copy this small right triangle DGM in a new page and we will analyze this small right triangle GDM. So actually, this is the small right triangle GDM that I copied from the original drawing. In this small right triangle GDM, it is very easy to see that cosine theta equals to dm over GD. So cosine theta equals to dm is the missing side, so we leave it as it is, over GD. GD is x, therefore we substitute GD by x. In conclusion, we actually found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally we get that according to this equation 1, dm equals to x times cosine theta. In the next step, we will define one side of this square ABCD is y, and therefore all the sides of this square ABCD will be equal to y, of course. So AD, side AD of the square is y. Side AB of square ABCD is also y. According to our definition, side BC equals to y, and side DC also equals to y. What is the definition of line segment AE? Line segment AE starts from point A, that is the center of the quarter circle, and ends at point E, that is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of the quarter circle. We define the radius of this quarter circle as R, therefore AE equals to R. So now we copy this right triangle ADE. In a new page, we will analyze this right triangle ADE. The hypotenuse DE of the right triangle AD equals to 12 units in its length according to what is given as the question. DE equals to 12. So actually, this is the right triangle ADE, the common from the original domain. In this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. So cosine theta equals to AE is R and DE is 12. So in total, actually, according to equation 1, we actually found out that, actually it is according to equation 2, this is equation 2, so according to equation 2, we actually found out that cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. So we have two equations. Now we can substitute cosine theta in this equation 1, by R over 12 for this equation 2. We do it now, and we get that according to equation 1, dm equals to x times cosine theta, and cosine theta is R over 12 according to equation 2. So in total we actually found out that dm equals to xr over 12. dm equals to xr over 12. This is side dm, that is equals to xr over 12. We have already found out that this quadrilateral DMNA is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side DM is equal to the opposite side AN. But DM is XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule, in the same rectangle DMNA, side DA must be equal to the opposite side MN, but DA is Y, therefore MN must be also equal to Y. In the next step, I'll copy again the right small target GM in a new page, and we'll continue to analyze this small right target GDM. Actually, this is the right target, the right small target GDM that I copied from the original domain. For the domain, it is very easy to see that sinus theta equals to GM over GD. So sinus theta equals to GM. GM is the missing side, so we leave it as it is, over GD. GD is X, therefore we substitute GD by X. In conclusion, we found out that sinus theta, according to equation 1, sinus theta equals to GM over X. Here we multiply this equation 1 by X, and finally we get that according to equation 1, GM equals to X times sinus theta. Okay. In the next step, I will copy again this right triangle ADE, and in the page we'll continue to analyze this right triangle ADE. So actually, this is the right triangle ADE that I copied from the original domain. In this right triangle ADE, it is very easy to see that sinus theta equals to dA over dE. So sinus theta equals to dA, that is y, over dE, that is 12. In total, we found out that sinus theta equals to y over 12. This is according to equation 2. Well, according to equation 1, we have already found out that Gm equals to x times sinus theta. So we have here two equations. Here we can substitute sinus theta in this equation 1 by y over 12 from this equation 2. We do it now, we get that Gm according to equation 1, Gm equals to x times sinus theta, and sinus theta is y over 12. So in total we actually found out that gm equals to xy over 12. Gm equals to xy over 12. So this is side gm, and it is equals to xy over 12. In the next step, we join points A and G together by straight line. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equals to R according to our definition. Actually, by joining points A and G together by straight line, we created the right triangle, triangle AGN. So I will copy this right triangle, triangle AGN in a new page, and we will implement the Pythagoras theorem in this right triangle, triangle AGN. Here by PT is the version for Pythagoras theorem. We just right now found out that the hypotenuse AG of the triangle AGN equals to R. It is also the radius of the quarter circle. We already found out that AN equals to XR over 12. And finally, what is the length of line segment GN or side GN? GN in total equals to GM plus MN. That is to say GN equals to GM, that is XR over 12, plus MN, that is Y. So in total GN equals to XY over 12 plus Y. So here GN equals to XY over 12 plus Y. Therefore AG equals to R and AN equals to XR over 12. Here by PT is a version from Pythagoras theorem. So actually, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. In the right triangle AGN, it means that AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equal to AN square. AN is XR over 12, therefore AN square is XR over 12 square, and XR over 12 square equals to X square times R square over 12 square, that is 144. So in total XR over 12 square equals to X square times R square over 144 plus GN square. GN equals to XY over 12 plus Y, therefore GN square equals to XY over 12 plus Y square. So actually, according to equation 1, we found out that R square equals to X square times R square over 144. Here we have xy over 12 plus y square. So we take y as a common factor from this expression. So y we second out as a common factor. So what is left from xy over 12 factor, we took from it y as a common factor. What is left is actually x over 12. And what is left from y after we took from it y as a common factor, what is left is actually 1 all squared. So if I found out that according to equation 1, r squared equals to x squared times r squared over 144. So here we have y times x over 12 plus 1 squared. So we use the algebraic identity that states that a times b to the power of m equals to a to the power of m times b to the power of m. And according to this algebraic identity, we get that y times x over 12 plus 1 squared equals to y squared plus x over 12 plus 1 squared. Because it is times. Again, y times x over 12 plus 1 squared equals to y squared times x over 12 plus 1 squared. Okay. So if I found out that according to equation 1, r squared equals to r squared times x squared over 144 plus y squared, and here we have x over 12 plus 1 squared. So we multiply 1 by 12 and then we divide it by 12 in order to have a common factor with x over 12. So in total the numerator will have x plus 12 divided by 12 squared. And here we have x plus 12 over 12 squared. We use the algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m. According to this algebraic identity, we get that x plus 12 over 12 squared equals to x plus 12 squared over 12 squared. 12 squared is 144. So in total, this expression according to this algebraic identity will be equal to x plus 12 squared over 144. So I write it down. Repeat again. This expression x over 12 over 12 squared according to this algebraic identity is equals to x plus 12 squared over 144. And I copy the other expression, it is not changed. So I can find out that according to equation 1, r squared equals to r squared times x squared over 144 plus y squared times x plus 12 squared over 144. This is equation 1. So in the next step, we will join points A and C together by straight line. Repeat again. We will join points A and C together by straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and then at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R according to our definition. By joining points C together by straight line, we get the right triangle ABC. So I copy this right triangle ABC in a new page and we implement the Pythagoras theorem on this right triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. Sides A, B, and C, they are both equal to y because of the fact that they are also the sides of square ABCD, and we know that all the sides of square ABCD, they are equal to y according to our definition. So, actually, this is the right triangle ABC that I got from the original drawing. Here by PT is the portion for Pythagoras theorem. On this right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. This is equation 2. So AC is R, therefore AC square is R square, and it is equal to AB square. AB is y, therefore B square is y square, plus BC square. BC is also y, therefore BC square is y square. So in conclusion, according to equation 2, we found out that R square equals to y square plus y square is 2y square. So according to equation 2, R square equals to 2y square. This is according to equation 2. Well, according to equation 1, we actually found out here that R square equals to R square times x square over 144 plus y square times x plus 12 square over 144. So we have here two equations. In both equations we have R square. Now we can substitute R square in this equation, equation 1, by 2y square from this equation, equation 2. We'll do it now. And we get that according to equation 1, R square is 2y square. And it is equals to R square, so R square is 2y square. And we have to multiply it by x square over 144 plus y square times x plus 12 square over 144. So we actually found out that according to equation 1, 2y square equals to 2y square times x square over 144 plus y square times x plus 12 square over 144. So here we divide this equation 1 by y square, and we get that according to this equation 1, 2y square over y square is 2. Here y square we get cancelled, and we left only with 2x square over 144 plus, here y square also will get cancelled, and we left only with x plus 12 square over 144. So here we multiply this equation 1 by 144, And we get that according to this equation 1, 2 times 144 is 288. Here 144 will get cancelled, and we left only with 2x squared. Plus here 144 also will get cancelled, and we left only with x plus 12 squared. So here we'll open the brackets of this expression, and we get that according to equation 1, 288 equals to 2x squared plus x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So actually found out that according to equation 1, $288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. So here we subtract 288 from this equation 1, and we get, according to this equation 1, here 288 plus 288 is 0. In the other side of the equation we have 3x squared plus 24x, and here we have 144 minus 288 equals to minus 144. So according to equation 1, we actually found out that 0 equals to 3x squared plus 24x minus 144. Here we divide this quadratic equation by 3, and we get that according to equation 1, 0 over 3 is 0, and it is equals to 3x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is minus 48. So we found out actually that 0 equals to x squared plus 8x minus 48. So this is a quadratic equation. Here we have here x squared plus 8x minus 48 equals to 0. If we again that this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we'll put those values of a, b, and c that we found for our specific quadratic equation in this general formula for x in order to find out the value of the values of x in our specific quadratic equation. We'll do it now and we'll get that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is minus 48, so minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. a is 1, so a is 2 times 1, that is 2. So we found out that x equals to minus 8 plus minus, inside the root we have 64 plus 192, that is 256 divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12. But x is the length of this 97GD, and x is a length, it must be a positive number, it can never be equal to minus 12, that is a negative number. So we cancel this solution and we will take into account only the positive solution for x. And the positive solution for x is as follows. X equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So I found out that the length of this 97GD is equal to x is equal to 4 units. And that is the answer to the question. In the next step, I'll summarize this lecture. Summarize the lecture. So, in the drawing, we have, so in this lecture, our mission was to find out the length of this line 7GD is equal to x. We have to find out the value of x. So in the drawing, we have a quarter circle, AFE is a quarter circle, inside this quarter circle we have this square ABCD. In addition, we know that this is line 7DE, that is equals to 12 units in its length. This is angle GDC, that is equal to theta. This is angle EDC, that is also equals to theta. Again, our mission is to find out the length of this line 7GD, that is equal to x. So, first of all, we know that all the angles inside any square are right angles, and especially it is true in square ABCD. So, this square ABCD, this is square ABCD, therefore those four angles, they're all right angles. In addition, we know that in any square, the opposite sides of a square are parallel to each other. Again, the opposite sides of a square are parallel to each other. In square ABCD, it means that side DC is parallel to the opposite side AB. Again, DC is parallel to AB in square ABCD. but side AB is part of the side line AE. Again, side AB is part of the side line AE. And we know that if a part of a side line is parallel to another side line, then the side line itself must be also parallel to the other side line. And therefore the side line AE itself must be also parallel to DC. So AE is parallel to DC. If we implemented rule 15, according to rule 15, alternating angles between parallel lines are equal to each other. Here, line A is parallel to line B. In addition, we have those two angles alpha and beta. Angles alpha and beta, they are defined as alternating angles, and they are located between the parallel lines A and B. Line A is parallel to line B. And therefore, they are equal to each other. That is to say, alpha equals to beta. So whenever we have two alternating angles that are located between two parallel lines, then they must be equal to each other. In this case, alpha equals to beta because line A is parallel to line B. Okay, so we can implement all 15 in our drawing. Why? Because in our drawing, we have first of all DC, line DC is parallel to line AE, and those two angles that are defined as alternating angles and they are located between the parallel lines DC and AE, and therefore they are equal to each other. So this is angle EDC, and it is equal to this angle, that is actually angle AED. Again, angle EDC equals to angle AED according to rule 15. Okay, they are equal to each other according to rule 15. Repeat again, angle AED equals to angle EDC according to rule 15. So this is angle EDC, but it is equals to theta according to what is given as the equation. So we can write here that angle EDC equals to theta, and from this equation theta equals to angle EDC equals to angle AD. We derive that this is angle AD, that is also equals to theta. So angle AD equals to theta. So this angle EDC equals to theta. Angle AD, this is angle AD, this is equal to theta. In the next step, we did a construction, that is to say, from point G, we go perpendicular on AB. Again, from point G, we go perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point between the perpendicular GN and side DC of this square as M. Okay, by doing this construction, created quadrilateral DMNA. This is quadrilateral DMNA. Inside this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. So inside quadrilateral DMNA we have 4 right angles. And you know that any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral DMNA that has 4 right angles as a rectangle. Okay. So GN is perpendicular on AB. So GN is a perpendicular, it is absolutely a straight line. So if you focus on the left side of this straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. That the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle. It is one out of 4 angles of rectangle ABCD, therefore it is equal to 90 degrees, plus this missing angle. So in total, the sum of those two angles, they must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size, and therefore the small triangle GDM is right angle. So I copied this small right angle GDM in a new page, and we analyze this small right angle triangle GDM. So actually, this is the right angle GDM that I copied from the original drawing. This is angle theta, according to what is given in the question. The hypotenuse GD equals to x, Also according to what is given in the question. So in this right triangle GDM, it is very easy to see that cosine theta equals to dm over gd. Cosine theta equals to dm over gd. dm is the missing side, so we leave this it is. gd is x, therefore we substitute gd by x. So in conclusion, in total we should find out that cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. Again, according to equation 1, dm equals to x times cosine theta. In the next step, we defined one side of this square ABCD is y, therefore all the four sides of square ABCD must be equal to y. That is to say, AD equals to AB equals to BC equals to CD equals to y. And what is the definition of side AE? Side AE starts from point A, that is the center of the quarter circle, and then at point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We define the radius of this quarter circle as r. Therefore, AE equals to r. And DE, the product DE equals to 12 units in itself, according to what is given as the question. So this is the right triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. AE is R, DE is 12, so in total cosine theta equals to R over 12. So according to equation 2, cosine theta equals to R over 12. For according to equation 1, we have already found out that dm equals to x times cosine theta. Now we can substitute cosine theta in this equation 1 by R over 12 from this equation 2. We did it and found out that dm equals to x times cosine theta. Cosine theta is R over 12, so in total dm equals to xr over 12. So here dm, this is side dm, is equal to xr over 12. But we have already found out that this quadrilateral dm NA is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle dm NA, side dm equals to the opposite side AN. But dm is xr over 12, therefore AN must be also equal to xr over 12. Likewise, according to the same rule in the same rectangle, dm NA, side dA must be equal to the opposite side MN. But dA is y, therefore MN must be also equal to y. In the next step, I copied again this small right triangle GDM in a new page, and we continue to analyze this right triangle GDM. This is the right triangle GDM that I copied from the original drawing. In this right triangle GDM, it is very easy to see that sinus theta equals to GM over GD. Again, sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is. GD is x, therefore substitute GD by x. So in total, we should find out that sinus theta equals to GM over x. Here we multiplied this equation 1 by x, and finally found out that according to equation 1, gm equals to x times sinus theta. Here I copied again the right triangle ADE in this new page, and we continue to analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. This right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Again, sinus theta, according to equation 2, is equals to dA over DE. dA is y, DE is 12, so in total sinus theta equals to y over 12. This is according to equation 2. Well, according to equation 1, we've already found out that gm equals to x times sinus theta. Now we have here two equations. We can substitute sinus theta in this equation 1 by y over 12 from equation 2. We did it and found out that the gm equals to x times sinus theta, and sinus theta is y over 12. Therefore, in total, gm equals to xy over 12. Okay, so gm, this is side gm, that equals to xy over 12. In the next step, join points A and G together by straight line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and then at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, it is the radius of this quarter circle that's equal to r according to our definition. So actually, by joining points A and G together by straight line, we created the right triangle AGN. So copied this right triangle AGN, and then we implemented the Pythagoras theorem of this right triangle AGN. This is the right angle AGN that is coming from the original drawing. We just right now found out that the hypotenuse AG equals to R. It is also the radius of the concentric circle that is equal to R. We have already found out that side AN equals to XR over 12. And what is the length of side GN? Here, side GN in total equals to GM plus MN. That is to say, GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. Here, GN equals to XY over 12 plus Y. So we implemented the Pythagoras theorem in this right angle triangle AGN. According to the Pythagoras theorem in this right angle AGN, AG squared equals to AN squared plus GN squared. AG is R, therefore AG squared is R squared, and it is equals to AN squared. AN is XR over 12, therefore AN squared is XR over 12 squared. XR over 12 squared equals to X squared times R squared over 12 squared, that is 144. So in total, XR over 12 squared equals to X squared times R squared over 144 plus GN squared. GN is XY over 12 plus Y, therefore GN squared is XY over 12 plus Y squared. So we found out that according to equation 1, R squared equals to X squared times R squared over 124. So we have here this expression, XY over 12 plus Y squared. Here we took Y as a second factor from this expression. So Y was second out as a second factor. So what is left from XY over 12 after what is left from XY over 12 after we took from it Y as a second factor? What is left is actually X over 12. And we have here Y. So what is left from Y after we took from it Y as a second factor? What is left is actually 1 all squared. So we should found out that R squared equals to X squared times R squared over 144. Here we have this expression Y times X over 12 plus R squared. Here we use, for this expression, we use the algebraic identity that states that A times B to the power of M equals to A to the power of M times B to the power of M. According to this algebraic identity, we get that y times x over 12 plus 1 squared equals to y squared times x over 12 plus 1 squared. And the other expression is not changed. We changed only this expression. Therefore, according to equation 1, we should find out that r squared equals to x squared times r squared over 144 plus y squared times x over 12 plus 1 squared. So we have here x over 12 plus 1 squared. Here we multiplied 1 by 12 and then we divided by 12. In order to have a common factor with x over 12. So in total in the numerator we will have x plus 12 divided by 12 squared times y squared plus r squared times x over 124 is equal to r squared according to this equation 1. So here we have x plus 12 over 12 squared. This expression, we can use the algebraic identity that states that a over b to the power of m equals to a to the power of m over b to the power of m. So according to this algebraic identity, we get that x plus 12 over 12 squared equals to x plus 12 squared over 12 squared, that is 144. So in total, according to this algebraic identity, x plus 12 over 12 squared equals to x plus 12 squared over 144. Repeat again. According to this algebraic identity, this expression will be equal to x plus 12 squared over 144. And the rest is not changed. Times y squared plus r squared times x squared over 144 is equals to r squared. This is according to equation 1. In the next step, I join points A and C together by straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R according to our definition. By joining points A and C together by straight line, we created the right angle, triangle ABC. So we call it the right angle ABC in the new page, and we implemented the Pythagoras theorem of this right angle, triangle ABC. This is the right angle ABC, the equivalent of the original domain. In this right angle triangle ABC, we just found out that the hypotenuse AC equals to R. It is also the radius of the quarter circle. Sides AB and BC, they are both equal to y. Both sides are also the sides of square ABCD. And according to our definition, one side of square ABCD equals to y. Therefore, all the other sides, they must be equal to y. So in this right triangle ABC, by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, AC square equals to AB square plus BC square. AC is out, therefore AC square is R square, and it is equals to AB square. AB is y, therefore B square is y square, plus BC square. BC is also y, therefore BC square is y square. So in total, we actually found out that according to equation 2, R square equals to y square plus y square, that is 2y square. So according to equation 2, R square equals to 2y square. This is according to equation 2, while according to equation 1, we have already found out that R square equals to R square times x square over 144 plus y square times x plus 2f square over 144. So here we have two equations. In both equations we have r square, and therefore we can substitute r square in this equation, equation 1, by 2y square for this equation, equation 2. We did it and found out actually that r square is 2y square. Here r square is 2y square times x square over 144, and we have here y square times x plus 2y square over 144. So after we substitute r square by 2y square in this equation, equation 1, we found out that according to equation 1, 2y square equals to 2y square times x square over 144 plus y square times x plus 2f square over 144. Here we divided this equation, equation 1 by y square, and we found out that actually that according to this equation, equation 1, 2y square over y square is 2. Here y square we get cancelled, and we left only with 2x square over 144. Here y square also we get cancelled, and we left only with x plus 2x square over 144. Here we multiply this equation, equation 1, by 144, and finally found out that 2 times 144 is 288. Here 144 we get cancelled, and we left only with 2x square. Here 144 also we get cancelled, and we left only with x plus 2x square. In the next step, we opened the brackets of this expression and found out actually that 288 equals to 2x square, and x plus 2f square equals to x square plus 12 square, that is 144, plus 2 times x times 12, that is 24x. So here we have 288 equals to 2x square plus x square is 3x square plus 24x plus 144. So here we subtracted 288 from this equation, equation 1, and found out actually that according to equation 1, 288 plus 288 is 0. In the other side of the equation we have 3x squared plus 24x, and here we have 144 minus 288 is minus 144. So here we divided this quadratic equation by 3 and found out actually that according to this equation, equation 1, 0 over 3 is 0, 3x squared over 3 is x squared, 24x over 3 is 8x, and minus 144 over 3 is minus 48. So actually found out that according to equation 1, x squared plus 8x minus 48 equals to 0. So this is the quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So now we have to take the values that we found for those values a, b, and c for our specific quadratic equation. We have to put them in this general formula for x in order to find out the value of the values of x in our specific quadratic equation. We did it, and we actually found out that x equals to minus b. B is 8, therefore minus b is minus 8 plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, so minus 4 times 1 is minus 4 times c, that is minus 48. Minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus, and 64 plus 192 is 256. So inside the order you have to leave 256 over 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution, for x equals to minus 12. But x can never be equal to minus 12 because of the fact that x is the length of this line 7GD. So x as a length, it must be a positive number. So, and therefore the negative solution for x is incorrect. So we cancel this negative solution for x. X can never be equal to minus 12. That is a negative number. Now we take into account only the positive solution for x. And the positive solution for x is as follows: x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. In conclusion, we found out that the length of this line 7GD is equal to x is equal to 4 units. Okay, thank you very much.